Welcome ladies and gentlemen, and thank you for joining me here. Today I want to give you my top tips how to print flexible filaments quite fast, so 60 millimeters per second and maybe above. Well, let's get right into it. First of all, the spool holders. As you might have seen, I use those spool holders. You want to have a spool holder where the filament rolls up pretty easily, but at the other hand it shouldn't be able to unwind itself. So they work out pretty well for me for this purpose. Second thing, the placement of the spool holder. If you're printing flexible and probably sticky material, you want to place the spool holder right in the middle of the inlet into the chamber. Or at least the filament should be able to be unwound at the perpendicular to the spool. As you can see here in this example, this really helps to get the sticky filament off the spool and reduces the forces and reduces the stretching of the material. Then you don't want to have any kind of tube, PTFE tube or whatsoever between the spool and the extruder, because even though it's a PTFE tube probably it still produces friction and it's harder for material to get to the extruder body or to the drive gears. And all of those things with the spool holder, placement of the spool and the tube, these things should guarantee that the filament gets loaded consistently. Because if it doesn't, then the filament might stretch a little bit and you get false alarms with the filament sensor, because it probably is an optical sensor and it just recognizes changes in the optical preferences, and if it's stretching, the optical preferences changes, and then it might give you an alarm depending on how sensitive it is. On the other hand, if it gets loaded when it's stretched, and after the drive gear you have some push forces, and so it compresses again, and then you will have less material loaded than you would need, and so you have to deal with inconsistent printing and under extrusions. The next thing, of course, is the extruder body. These are extruder bodies of some iterations of the i3 MK3, and I didn't put too much effort in the upper side, so the filament is coming from here, and here are the drive gears. It's a Bondtech system with 2 drive gears, and I didn't put too much effort in the upper section. That gives me a little bit of drawback when it comes to retraction, but it works. The other thing very important is you want to fill those gaps between the drive gears and the pushed material, so underneath the gears in direction to the hot end. It's not just about cutting a PTFE tube in a V shape or something, but you really want to fill up those gaps. And there's one more thing. A lot of drive gears have kind of a hollow shape let's suppose this is the diameter of the material of the filament, and the drive gears have kind of a cutout to warp a little bit around the material. Now if you make a guide or an inlet guide or a V shape, then you still have this gap here of the hollow drive gear, and you want to fill up this one as well, because that was the last position where my filament still popped out of the extruder. So the extruder body design and the inlet guidance is all about getting rid of the pushed out material and leading the push force down into the hot end. If you are not able to completely redo your extruder body, then probably just make something like for example, this is the filament guidance of E3D Titan Aero extruder, and it's pretty good. It has not only a V-shaped or a triangular shape, but also it has some round surfaces to match up with the shape of the drive gear and the bearing, the idler bearing. But still they don't have those gap closeners here and there, and this is why you can't print too fast with the E3D Titan extruder. although it works pretty good, but not perfectly. So what you could do is, if you have, for example, this is the original extruder body, it has just a small inlet guidance, and the PTFE tube is supposed to stick out like this. And what you could do is just print something that you can place over here, and maybe you connect it with the PTFE tube so it stays in place. But have this filament be guided into the extruder body, into the hot end. Very, very important. If you want to make the extruder body perfect, then be sure that the path of the filament is very, very straight downwards. And that includes the drive gears, both drive gears, or if you have a Bondtech system, both drive gears. And if you have a bearing idler, this position as well. You don't want the drive gear to be off-centered. If this is the drive gear, or this is the drive gear, and probably this is a bearing, and this is the filament path as it should be. A lot of drive gears are pretty much to the center, and then the drive gear is like this. The idler is like this, and if you follow the filament path, then it has to wind itself around here, and this will lead in a misdirectional push force, so it won't push straight downwards but a little bit to the side, and that of course supports the effect of the filament popping out of the extruder. So we want to center it out, and then the tension on the idler isn't that important anymore. It still is important that you don't over tighten it, but with the gap closing thing and the positioning of the gear and the idler fixed, or using Bondtech both gears fixed, I don't have to change my idler tension anymore. I do use the same tension for flexible materials, rigid materials, polycarbonate, PETG, PLA, everything the same tension. I do never touch the tension again because it just works, and that's great. Now, tip number 5, and this is kind of a top tip to me because it made the largest differences for me. If you're printing something like this, there's no point in using a small 0.4 or 0.5 millimeter nozzle. So go ahead and give the larger nozzle diameters a try. For example, use a 0.8 if you're regularly printing with a 0.4 millimeter nozzle, then go for a 0.8 millimeter nozzle. And if you want the walls to be just 0.8 millimeters thick, then make 1 perimeter. You will have the same amount of material, but printing flexibles will be far easier with a larger nozzle. So obviously, spool holders, you should be able to do that very easily. The spool position, you can handle that. But if you can't modify your extruder body, I highly recommend to go with a larger nozzle. Not are you only printing a larger amount of material, so you're faster anyways, but you can ramp up the speeds. And if your hot end is powerful enough, you don't have to raise the temperature. So there you go, these are my top tips here. Now I rushed over it. It's about the 4th attempt of me making this video, and all the footage is hours long, and I decided to make a short condensed information video now. And if you want some detailed information, then leave a comment and ask for it. Another thing I want to do at this place, I want to thank those guys in the Prusa forum. Now we had there a very positive discussion and conversation going on with a lot of guys dealing with flexible materials. So again, thank you very, very much for your help and for this great conversation there. You definitely should check out the forum or this specific thread. I will link it down below. And all the information I gave you here, they're not only my work, but theirs as well. So give credit to them and their awesome work. Absolutely fantastic dudes there. Other things I want to link down below is a link to the spool holders I use You can find them on Thingiverse very easily. Just if you look for spool holders, they will pop out right away. But I will link down the specific ones I used. What else I want to link is the extruder body from the Prusa i3 MK3 that I'm using now. And what we have to change as well is the X carriage and the idler, because to get this filament path straight, we needed to move the stepper position a little bit to the left, and as there is a screw going through the X carriage and to the extruder body, we had to take this offset at the carriage as well. And to make it perfectly aligned, the position of the gear on the idler had to be changed as well. So it's a set of 3 parts: the X carriage, the extruder body, and the idler. Following those steps eliminated the need for those conventional steps you had to do to get this flexible material to print, which are printing slow, obviously, loosen the tension on the idler, and raising the temperature. So see the links down below. If you want to have some detailed information, feel free to comment. If it helps, or if you liked the video, hit the like button and probably the subscribe button as well, if you don't want to miss some upcoming information. Just stay tuned and happy frustration-free flexible printing. If you have some other suggestions how to print flexible materials better, faster, easier, leave a comment as well. Maybe we can start a kind of conversation here and make it even better.